Example 3. Find the derivative of the given functions. For the chain rule, we could use either version 1 or the version 2 of the derivative. The version 1 is dy by dx equals the product of the derivative of the y with respect to u and the derivative of the u with respect to x, where u is the inner function, or the version 2, which is the derivative of the composite function f of g is the derivative of the function f as the gx as input multiplied by the derivative of the gx or the inner function derivative. For part A, we have y equals 2x to the third plus 5x raised to the power 6. Let u be 2x to the third plus 5x. That gives us y equals u to the power 6. To find the derivative of dy by dx, we use the first version, which is the product of the derivative of the y with respect to u and the derivative of the u with respect to x. As y equals u to the 6, the derivative with respect to u is 6u to the fifth, and the derivative of the u with respect to x is 6x to the second plus 5. Next step, we replace u with the quantity 2x to the third plus 5x to get 6 multiplied by 2x to the third plus 5x to the fifth power multiplied by 6x to the second plus 5 as the answer. Part B, y equals the square root of 1 minus 7x. We rewrite it as the quantity 1 minus 7x to the power 1 half. In this case, we can see u as 1 minus 7x, and the function y is the square root of the u, or u to the 1 half power. The dy by dx, or the y prime, is the product of the dy by du and the du by dx. Y is u to the power 1 half, so the derivative of the y with respect to u is 1 half u to the negative 1 half power multiplied by the derivative of the u with respect to x, which is 0 minus 7, or just negative 7. Next step, replace u with the quantity 1 minus 7x to the power negative 1 half and multiply by negative 7. And we can simplify a little bit more by rewriting as negative 7 divided by 2, and the negative power 1 half to become positive power. We rewrite it as the reciprocal. And then also the power 1 half, you can write as the square root. So the final form of this derivative is negative 7 divided by 2 times the square root of 1 minus 7x. Part C, we have y equals 5 divided by the quantity 3x plus 1 to the power 10. We're going to rewrite it as the negative power as 5 multiplied by 3x plus 1 to the power negative 10. And let u be 3x plus 1. Now the function y is in the form of 5 times u to the negative 10th power. Y prime, or dy by dx, as the product of the derivative of the y with respect to u and the derivative of u with respect to x. Y is 5 times u to the power negative 10th. The derivative is 5 times negative 10 times u to the negative 11, and then multiply by the derivative of the u with respect to x, which is the derivative of 3x plus 1 to get 3. Simplify the term, replacing u back with the 3x plus 1. Now we get 5 times negative 10 times 3, which is negative 150. U to the negative 11 is the same as the reciprocal with the positive power, and the u is 3x plus 1. Now raised to the power 11 as the denominator. Part D, y equals e to the power tangent x. The inner function is the tangent x. Let u be the tangent x. The function y is in the form of e to the power u. The derivative or the y prime is the product of the derivative of the y with respect to u. Or dy by du multiplied by the du by dx. The y is e to the e to the u. The derivative is e to the u, and multiplied by the derivative of the u with respect to x. The derivative of the tangent x is the secant square x. Next step, replace the u with the tangent x. We get e to the power tangent x multiplied by the secant square x. Part E, we have y equals cosine to the second power of the x. As you see, part F is in the similar form. Part F, we have y equals cosine of x squared. These two are very similar, but they have different meaning. Let's look at part E. Part E, y equals cosine to the second x. That means we have the cosine x multiplied by itself twice, or the second power of the cosine x, where part F is the cosine of the quantity x squared. In part E, as y equals cosine x quantity power 2, let u or the inner function cosine x that gives us the y equals u to the second. To find y prime or the product of the derivative of the y with respect to u and the derivative of the u with respect to x equals 2u for the derivative of the y with respect to u multiplied by the derivative of the u with respect to x, which is negative sine x. Replace u with the cosine x to get 2 times cosine x times negative sine x. And then we write it as negative 2 times cosine x times sine x as the derivative for part E. In part F, we have y as cosine of the quantity x squared. This time we're gonna let u be x squared, or the inner function is x squared. So the y is the cosine of u. Y prime, or the dy by dx, is the product of the derivative of the y with respect to u and the derivative of the u with respect to x. The y is cosine u. The derivative is negative sine u, and multiplied by the derivative of the u with respect to x, which is 2x. Replace u with the x squared to get negative sine of x squared multiplied by 2x. Rearrange the term to get negative 2x times sine of x squared. The last example, y equals the cube root of sine of 3x minus x to the 6th. This one we can treat it as the quantity sine of 3x minus x to the 6th to the power 1 over 3. And then we're going to use different version of the chain rule to find the derivative, since the inner function has another composite function involved. So the derivative, the dy by dx, or the y prime, is the derivative of the outer function, which is the power 1/3, multiplied by the derivative of the inner function, which is sine of 3x minus x to the 6th. We treat the whole inner function as one quantity of the input. So the derivative of some quantity to the power 1/3 is 1 over 3 of that quantity to the power negative 2 over 3. Remain the input as the whole sine of 3x minus x to the power 6. And then the next one is the derivative of the inner function, which is the derivative of psi of 3x minus the derivative of x to the power 6. For the first group here is 1 over 3 multiplied by 1 over the psi of 3x minus x to the 6 to the power 2 over 3. The derivative of psi of 3x, that is another composite function. The outer function is the psi function. The inner function is 3x. So we can use the derivative of the psi x, which is the cosine of the input, multiplied by the derivative of the input, which is 3, minus the derivative of x to the 6, which is 6x to the 5th. Rewrite the terms. Now we have 3 times cosine of 3x minus 6x to the 5th, all divided by 3, multiplied by the quantity psi 3x minus x to the 6 to the power 2/3. We can simplify a little bit more as we see 3, 6, and 3. The common factor would be 3. So factor the 3 out to get the cosine of 3x minus 2 times x to the 5th divided by 3 times the quantity psi of 3x minus x to the 6 to the power 2/3. 3 and 3 can be reduced, so the final answer would be cosine of 3x minus 2x to the 5th, all divided by the quantity psi of 3x minus x to the 6 to the power 2 over 3.